For the Unit 2 review, we're just going to go over some key points for your test tomorrow. The first one is solving with a fraction. If your fraction is outside of the parentheses, like this example, we're going to want to get rid of the fraction first. You could distribute the 1/3, but then you're just going to have two fractions. So on this one, to get rid of the 1/3, we're going to multiply by the reciprocal on both sides. Here's my algebra wall. And by doing that, we cancel the fraction on this side to make w plus 1. And on the right side, 8 times 3 is 24. Now, to get w by itself, all you have to do is subtract the 1 over. Remember, the opposite of addition is subtraction, and we're left with w equals 23. We're done. Now, don't forget on your test to check every single time. We check by plugging in our answer for the variable. So this one becomes 1/3 times 23 plus 1 equals 8. 23 plus 1 is 24. And 1/3 of 24 is actually 8, so I know we did it right. Another example of a fraction problem is this one. Here, I need to get x by itself. The fraction isn't actually outside of parentheses. So here, if I draw in my algebra wall, the opposite of adding 16 to x is to subtract it. We're going to go ahead and subtract it over. Don't let the 0 throw you off. 0 minus 16 is negative 16. And on the left side, I have 4 over 16 x. Now to get rid of the 4 over 16, I'm going to multiply by the reciprocal. And this cancels on the left, so we're left with x. And on the right, 4 goes into 16 4 times, and negative 4 times 16 is negative 64. We can plug that in to check as well. The next example has a set of parentheses with a negative in front. A common mistake I see here is people try to distribute that 7, but that's incorrect. This negative sign actually acts as if there's a negative 1 in front of our parentheses. So our first step on this problem is to distribute a negative 1. Basically, we're just changing the signs to the right of the problem. Okay, and on the right-hand side, we can actually go ahead and combine like terms. 4h and negative 3h give us 1h, or just h, plus 13. There's one like this on your test, so make sure you pay close attention. From here, I need to get my h's on one side. So I have a negative 3h on the right, a positive h on the left. I'm going to move the smaller one over. The opposite of negative is to add. And by doing that, I'm left with 4h plus 13 equals 7 minus 2. I'm going to simplify that down. 7 minus 2 is 5. Now I'm going to subtract 13 from both sides. I'm left with 4h on the left, and 5 minus 13 is negative 8 on the right. Divide both sides by 4, and we're left with h is negative 2. For the sake of time, I'm not going to check it, but make sure you check it on your test. The next kind of problem we had was inequalities. If we read this out loud, this says 12 minus x is greater than 13. Remember, the alligator eats what's greater. So to solve this, I need to move over the 12. This is positive 12, so I'm going to subtract 12 over to cancel it. Remember, whatever you're canceling needs to equal out to 0. Now don't forget to bring down the negative with the x. 13 minus 12 gives us 1 on the right, so we're left with negative x is greater than 1. Do not stop there. We have to get positive x by itself. So this is the same thing as having negative 1 times x. We're going to divide both sides by negative 1. So we're left with x on the left, and we're left with negative 1 on the right. I divided by a negative, so I have to flip my sign. Don't forget to flip that sign if you multiply or divide by negative. If you start with an inequality sign, you need to end with an inequality sign. The second part of the inequalities is to graph them. At negative 1, I'm going to have an open circle because it's not underlined, and x is less than for this problem, so I'm going to shade to the left. Make sure you can shade for your test. The other type of inequality problem that we saw was compound inequalities. This is an example of an and inequality. If they are connected like this, this means and. You can separate this and put and in the middle and solve it separately if you would like. But if you're going to do it with two algebra walls, then whatever you do in the middle has to happen to all three sides. We're going to cancel out that negative 7 first because I want x by itself. So I'm going to add 7 to all three sides. Negative 4 plus 7 is positive 3. I have 3x in the middle, and I have 15 on the outside. Now I still want x by itself, so I'm going to divide all the sides by 3. And we're left with 1 is less than x, which is less than 5. Now we can't forget to graph it. At 1, I have an open circle because it's not underlined, and at 5, I have another open circle because it's not underlined. X is greater than 1. The alligator's eating the x, so from 1, we're going right. And x is less than 5, so we're going to go left. Just think of it as two separate graphs in one. Now, you might see something like this on your test also, where it's a word problem and you have to make a graph out of it. So I want you to take it word by word. This says x is greater than 5. So from there, we know x is greater than 5 would look like this. Or means that we have an or problem. Or x is less than or equal to negative 4. We're just making two equations out of our word problem. So from the graph, at negative 4, I have a closed circle because it's underlined. It's or equal to. Don't confuse this or with this or. And since x is less than or equal to, we're shading left. And then for x is greater than 5, I have an open circle because it's not underlined. And we're shading right because it's greater. Remember, or problems are going to shade out, and problems like our last one is going to shade in. Now here I'm going to actually create a graph for us to come up with an inequality. You might have to work backwards from a graph. So for here, I know I have a closed circle at 2 and I'm shading right. Right always means greater than. So for just this left part, I know that x is greater than or equal to 2. We're not even going to look at the right part of the graph yet. Then for this side, I know I'm shading left, so I know that x is less than 5 because it's an open circle. Since this is going in, I know that it's going to be an and equation. You have to have this word in between. Also, you could write an and equation like this. 2 is the least, 5 is the biggest, if you look at our bounds on the line graph. I know that x is greater than 2, and I know that it's greater than 5. I would take either one of these answers, but you have to have the and if you're going to keep them separate. The last problem that we're going to go over for your test is one like this. It says the rectangle above has a perimeter of 30. Write an equation and solve for x. Well, we know perimeter means all the sides added up. So to figure out what x would be, I'm going to add this side plus this side plus this side plus this side, and it should equal 30. So we have x plus 2x plus 4 plus x plus 2x plus 4. Those are my four sides, and I know it's going to equal 30. We know how to solve for x from here. I have x, 2x, x, and 2x. That makes 6x total. I have 4 and 4, which is 8. I want x by itself, so we're going to subtract 8 from both sides. And we have 6x equals 22. And then from here, I'm going to divide by 6. It's okay to get a fraction. I just want you to simplify it, which would be 11 over 3. If you have watched this video, taken good notes, and done the odd on the review I gave you, you should be good to go for the test. Make sure you check your answers with mine.